Okay, we're looking at, we're studying electrochemistry, and electrochemistry is all measuring how likely a reaction is to occur and how much potential is available. And we're looking at, in this case, electrons moving from being with one element to another. So where is it going to be, where's the electron going to be more stable? And electrons will tend to move to a place where they're more stable, and that makes a reaction have a tendency to occur, and that's where you're going to get that's where your potential is going to come from. And that's like whenever something's becoming more stable, there's a way for you to get energy out of this reaction. So it's the driving force of electrons finding a more stable place. So since we care about where the electrons are, or where they're moving, we have to be able to figure out where electrons are. The way we do that is we figure out oxidation states. Oxidation states are just the charge of the atom. Charges occur because, bonds are just the sharing of electrons. In some bonds, an atom will, in effect, take the electrons from another atom, and then the atom that takes electrons ends up being negative. Sometimes an atom will lose its electrons to another atom. So we can figure out the charge of an atom by figuring out if it's likely to gain or lose electrons with whatever that atom is with. But let's see, there's going to be a few charges that end up being weird. Like we're used to looking at the periodic table and saying that first column should be a +1, the second column should be, a +2, the halogen should be a -1. When we look at oxidation states in electrochemistry, we'll see some sharing that leads to weird charges. So we need rules. So the rules are going to be whenever something's by itself, that thing has a charge of 0. And that's because if I have sodium solid, sodium metal, then I have a bunch of sodium atoms, and no one sodium atom is going to be more electronegative than another sodium atom. So you're not going to have the electrons closer to one atom or another. You're not going to have a positive or a negative charge. Same with chlorine. Cl2, two chlorine atoms are going to share their pair of electrons equally. So any element by itself is going to have a charge of 0. When you have alkalis will still be a +1, so we get to apply that rule. Oxygen will be a 2-, unless it's peroxide. Your clue that you have peroxide is that you have O2 in your formula, or some multiple of O2, and it's weird. So hydrogen is always a 1+ unless there's an alkali metal. If it's with an alkali metal, well, we see the charge of the alkali and then figure out what the hydrogen has to be. And oxidation states will always add up to the charge of the compound. So this has no charge, H2SO4, no charge written. The charge of these 3 elements will add up to 0. This guy, PO3, 3-, has a -3. These charges will add up to a -3. So we did these in class. We'll do the next slide. So at this point, because you've seen these before, you should pause, try these 6, and when you're ready, hit play. So I'll go ahead and show you the answer. Hopefully you've already figured them out, and you can check yourself to make sure you're doing this right so you're ready for your next quiz. So this has a charge of 0. There's no charge written. So these guys will have their charges add up to 0. Potassium's an alkali metal. That was the first rule. It's going to be a 1+. Okay. 1+ plus something plus oxygen was the next rule down. And it's always a 2- unless I can't make that work. So I've got -2 for each oxygen. There's 4 oxygens, so -2 times 4. This is a -8. Okay, so basically I need +1 plus something -8 will equal 0. So I'm going to need a +7, right? 1 plus 7 is 8. 8 minus 8 is going to be 0. So that means the potassium equals a +1, the manganese equals a +7, and the oxygen equals a 2-. Okay, and then here I have dichromate, Cr2O7 with a 2-. All of these charges will add up to 2-. I'll look at the oxygen first. I'm going to assume it's normal, so -2 times 7 is -14, right? So then I want 2, because there's 2 chromiums, 2 times something, -14 will equal a -2. Okay, so basically I'm going to need 12 minus 14 is equal to -2. So 12 divided by 2 is 6. So 2 times 6 is 12, minus 14 gives me a -2. So the chromium, each chromium will have a 6+ charge, and each oxygen will have a 2- charge. Okay. Then H2O2, it's clearly weird because I'm used to H2O. This is a multiple of 2, so this O2 must be peroxide. Okay, so that means each oxygen is a 1 minus, and that means each hydrogen is going to be a 1 plus. And then they'll balance each other out. So H equals 1 plus, O equals 1 minus. Then I have ClO4 with a 1 minus charge. So these guys' charge will add up to a negative 1, right? I'll start with the oxygen. 2 minus, 2 times 4 is 8. So this is a negative 8 for my oxygens. I need something minus 8 to give me a negative 1. That chlorine must be a 7 plus. That's weird. I'm used to chlorine being a 1 minus, but here it's a 7 plus. So Cl equals 7 plus, oxygen equals 2 minus. Notice the oxidation state is the charge on one of the atoms, right? There's 4 oxygens for a total of a negative 8, but one oxygen is going to be negative 2. Then I have Kh. So alkali metals were the first, they're at the top of my rules. So this is a 1 plus. And this will add up to 0 because there's no charge written. So 1 minus 1 would equal 0. So my K equals 1 plus, I'm used to that. My H equals 1 minus. It's weird, but so it is. And then here I've got O2. This, one oxygen isn't going to be more electronegative than the other, so they're going to share electrons equally. So there's no overall oxidation state. So oxygen equals 0.